So here's another issue of where we have angle, side, side. Okay, I think CK12 uses side, side angle, but really we have an angle, a side, and a side. Okay, so what happens is because we only have one angle, the shape of this triangle is not necessarily fixed. Okay, now this angle is obtuse. It's drawn obtuse, but it doesn't necessarily have to be obtuse because when we look at this triangle, it is possible that this triangle, this length of 5, okay, since this top angle is not fixed and the length of the bottom line is not fixed, this angle, the top angle of 5 could end up going down here like this, okay, and forming an acute angle. Okay, so there is my angle here. Okay, now we have to recognize that this is an ambiguous case, and there are two possibilities here that we have to worry about: the black triangle and the orange triangle. Okay, so first things first, we need to recognize that we have an angle and opposite side pair that relates to sine law. So I'm going to set up my ratio, sine of 22 degrees over the opposite side 5. So there's my angle and opposite side pairing. Okay, that ratio is going to be the standard of which I compare everything else to. So I want to say, I'm going to call this angle, I'm going to call this C1. And we know that sine of C1 over 11, okay, angle opposite side pair, is going to be equal to the known angle and opposite side pair. So I go ahead and solve for C1. Okay, so that's C1. So I'm going to get sine of angle C1 is equal to 11. Okay, so just going to cross multiply there, 22 degrees over 5. Okay, so I get the sine of angle C1 is equal to, what is that decimal value first? So let's go sine 22 degrees times 11 divided by 5. And I get 0.824. 0.824. Okay, so I'm going to undo that sign with an arc sign. So input my ratio, my angle is my output, and C1 is going to be 55.50 degrees. Okay, so it's going to be 55.50 degrees. Now, I really shouldn't have said that one was C1 because that is my acute angle. And the sine, if anytime you do an inverse sine or undo the sine, you're always going to get angles between negative 90 and positive 90 degrees. So we'll never get an obtuse angle from that, from our calculator. So our theta 1 is always going to be acute in this case. And so that's going to relate to the orange triangle. Okay, so I'm just going to highlight that. Okay. But let's solve for the black triangle first, because that's one that's kind of drawn for us. So we need C2. Okay. Well, C2, if you take a look at the diagram, see our first angle that we solve for, this is an isosceles triangle, so those two angles are same. So to find the angle C2 on this side, it's just supplementary. So it's going to be 180 degrees minus theta 1. Okay, which is exactly the same formula that we use for theta 2 when we deal with circle trig. So we end up with 180 minus theta 1, okay, which is 124.5 degrees. Okay, and although it's not quite drawn accurately, that is our obtuse version, and that is our acute version. Okay, so I'm going to write this in as 124.50 degrees. And that allows me then to solve for the angle in here, which I'm going to call B2, angle B2. Okay, we're just going to subtract from 180, so we're going to 180 minus 22 minus our 124.5, so we get 33.50 degrees. So 33.50 degrees. Okay, so angle B2 is equal to 33.50 degrees. Okay, so I'm just going to highlight those because those are my angles I'm solving for. I'm also going to solve for B. I'm going to call that B2. And using the sine law, we're going to solve for B2. Okay, so I'm just going to do that over here. So side B2 over sine of 33.50 degrees, okay, is equal to 5 over sine 22. Again, I'm using the sine law, solving for side B2. Okay, so I'm going to do sine of that angle times 5 divided by sine of 22 degrees, and we end up with 7.37 about. Okay, so if you're off by a little bit, it's usually going to be due to rounding. So there's my three parts of the unknown parts of this triangle that I've solved for. Now that's for the black triangle. Now this is an issue with ambiguous case. So when we have angle side side, we have to consider that it could have been this 55.50 degrees. Okay. Well, if that's the case, then that makes my, I'm going to call this B1, angle B1, then would be comprised of, I'm just going to write in that angle here, this is 55.50 degrees. So B1 would be 180 minus 22 minus 55.5, and that gives us 102.5 degrees. Okay, so this angle up here could have been the obtuse angle of 102.50 degrees. Now, this diagram isn't all that accurate. If you kind of look at the lengths and the proportional lengths are actually quite a bit off. So the diagram can be deceiving, and we can't really go by the diagram. We have to go by the lengths of measurements given. So now I've got a different angle for these two. That means I'm also going to get a different side here, which I'm going to call B1. Okay, this longer length here we're going to call B1. So let me just move this out of the way. So that's angle B1 is going to give rise to side B1. So I'm going to write the relationships. B1 over sine of 102.50 degrees. Remember, we have our angle and opposite side pairing, and that's going to be equivalent to my original angle and opposite side pairing, 5 over sine of 22 degrees. Okay, so I end up with the length B1. B1 is equal to, it's going to be 5 times sine 102.50 degrees over sine of 22 degrees. And solving for B1 then, I get 5 times sine of 102.5 divided by sine of 22. And again, because we're doing a lot of decimals here, you're going to have a little bit different answers depending on your rounding. So my rounding gives me B1 length as 13.03. Okay, so there is my three parts of the triangle, C1, B1, angle B1, and length B1. Those three unknown parts are different than the parts I solved for the black triangle, and because these are two possibilities, when we have angle side side, we have to always account for the fact that we have to solve for now two triangles.